Today I will be discussing starch and cellulose. Cellulose first appeared in 1839 on Anselm Payne's research on lignous matter, the term then for the combination of lignin and cellulose that forms the woody cell walls of trees and other plants. In 1838, Payne reported that lignous matter, then considered a single substance, contained two chemically distinct materials. One of these, he revealed, had the same chemical composition as starch, but differed in structure and properties. One of the earliest forms of starch being used was by the ancient Egyptians. They used a starch paste to cement strips of papyrus stems together to use as writing paper as early as 4000 BC. Later, starch was used to stiffen linen in northern Europe in the 14th century. Cellulose and starch are very similar but very different at the same time. Some of those differences are found in the structure of the two polymers. The structures are different since the acetyl linkage in cellulose is beta and the acetyl linkage in starch is alpha. This small difference in acetyl linkages results in the difference between if humans can digest it or not. Both starch and cellulose are made from the monomer glucose. Starch is a soft, white, tasteless carbohydrate powder that is not soluble in alcohol, cold water, or other solvents. Cellulose is a tough, insoluble in water, fibrous polysaccharide that is biodegradable. Cellulose is found in all plants and plant products. Cellulose is the substance that makes up most of a plant's cell walls. Since it is made by all plants, it is one of the most abundant organic compounds on Earth. Other than being the main building material for plants, cellulose has other applications that it's used in. Based on how the cellulose is treated, it can be used to make paper, film, explosives, and plastics. Of the many cellulose derivatives, cellulose acetate is the most stable. Cellulose acetate is a crystal clear, tough, and flexible plastic. Cellulose acetate can be put into two types, cellulose diacetate and cellulose triacetate. Important uses include textiles and fibers. Another important cellulose derivative is celluloid. Celluloid is the oldest thermoplastic invented in 1855. Celluloid has good mechanical properties but has poor weathering and heat resistance. Celluloid is very flammable, which makes it too hazardous for most applications. The main application of celluloid are a binder in products like inks, coatings, and adhesives. Starch is a mixture of two polymers, amylose and amylopectin. Starch is the most important source of carbs in the human diet and accounts for more than 50% of our carb intake. The most common applications that you think of when you think of starch is in cooking applications. There are other applications that starch is used for. Starch can be used in pressing clothes to keep them from wrinkling. Also, starch is used to make foam packing peanuts since the starch is biodegradable and can dissolve in water. The most common thing starch is used for is as a food additive. Starch is used in food to make different types of foods thicker, such as pudding and gravy, and can be used to provide a better flavor while cooking. Starch and cellulose are very similar in ways, but there is one major distinction between the two. Humans can digest starch but cannot digest cellulose. Humans lack the enzymes needed to digest cellulose. Grasses and hay are abundant in cellulose which cannot be digested by humans. Animals such as termites, cows, koalas, and horses can all digest cellulose, but they also do not have the proper enzymes to digest it. These animals instead have microbes that can digest cellulose. Although cellulose cannot be digested by humans, it does form part of the human diet in the form of plant foods. Small amounts of cellulose found in vegetables and fruits passes through the human digestive system intact. Cellulose is part of the material called fiber. Starch-based plastics is a bioplastic that is widely used. These materials can be injection molded or extruded using normal processing equipment. These starch-based plastics are generally cheaper compared to other bioplastics. These plastics have a better tensile strength and heat tolerance when comparing them to other bioplastics. Packaging is one of the biggest growth areas for these starch-based plastics. The future of starch is not the only material that's growing. There are also applications that are being explored using cellulose materials. Cellulose nanocrystals are distinct nanomaterials that are made from the natural polymer cellulose. Its tensile strength is like that of aluminum. The stiffness is comparable with that of Kevlar, and films made from this material have high strength, high stiffness, and high strain. The material's ability to adapt is a promising feature for it to be used in biomedical applications. Starch and cellulose are two very similar but also very different polymers. The major difference between the two polymers comes from the structure. Starch has an acetyl linkage with an alpha bond, while cellulose has an acetyl linkage with a beta bond. The difference in the bonding affects things such as whether humans can digest it and the applications that it is used for. Common applications for starch are used in cooking as a thickener, and cellulose applications include paper, film, and explosives. Starch and cellulose are both biodegradable and come from the monomer glucose. Applications that will continue to grow in the future include packaging applications using starch-based plastics since the material is biodegradable, and using cellulose in biomedical applications.